Hello everyone, welcome back. In the last lecture, we solved the cost minimization problem and find that the total cost of a firm is a function of its output level. Next, we will distinguish between short run and long run and see how the cost of a firm changes with the output level. Previously, we have introduced the definition of short run and long run in the production part. In the short run, factors of production can be divided into fixed production factor and variable production factor. Accordingly, short run cost can also be divided into fixed cost and variable cost. Fixed cost refers to the cost of the firm's production cost that does not change with the changes in output level. It usually includes infrastructure construction cost, or rents, or machinery and equipment expenditures, recruiting expenditures, insurance premiums, and asset depreciation. In a certain period of time, these costs have nothing to do with the output level, even if the firm does not produce any output, since the fixed production factors have already been invested. The fixed cost still exists. So even if the output is zero in the short run, producers still have to bear fixed cost. Variable cost refers to the cost that changes with the output level during the production process, such as the cost of raw materials and parts, the wages of workers, the fuel and power cost, etc. When the output is zero, the producer does not need to pay variable cost. When the output increases, the variable cost increases. In other words, fixed cost is a constant number that has nothing to do with the output level, and variable cost is a function of output level. We use the horizontal axis to represent output level and the vertical axis to represent cost. The fixed cost is a horizontal line because no matter how the output changes, the fixed cost remains the same. The vertical sum of fixed cost and variable cost is the short-run total cost. Because the fixed cost is a constant, the vertical distance between the total cost and the variable cost is this constant. In the short run, increasing production means that producers need to use more variable factors, so variable costs and total cost increases as production increases. But the two curves usually have a turning point when the output reaches a certain level, such as shown by Y0 in the figure. Before the output reaches Y0, the slope of these two curves is decreasing. After the output exceeds Y0, the slope of these two curves is increasing. In other words, the variable cost and total cost curves both show a trend of slow growth followed by a rapid growth. This trend comes from the diminishing law of marginal product that we learned earlier. Before the output reaches Y0, marginal product of variable factors is increasing. That is, the marginal number of input that needs to be added for one additional unit of output gradually decrease. So the total cost and variable cost have decreasing growth rate. After the output reaches Y0, the marginal product of factors is decreasing. That is, the marginal number of input that needs to be added for one additional unit of output gradually increase. So the total cost and variable cost have increasing growth rate. Knowing the total cost function, we can find the average cost per unit of product, which is equal to the total cost divided by the output level. Since the short-run total cost can be divided into fixed cost and variable cost, the short-run average cost is also equal to the sum of average fixed cost and the average variable cost. How does the short-run average cost change with changes in output level? Since the short-run average cost is composed of two parts, the average fixed cost and the average variable cost, let's first look at these two parts. Since the fixed cost is always the same, the average fixed cost will inevitably decrease as the output increases. As shown in the figure, the AFC curve slopes downward and gradually approaches to zero. The average fixed cost is the difference between the average cost and the average variable cost, so that as the output increases, the average cost will gradually approach to the average variable cost. We have just said that as output level increases, variable cost increases slowly first, and then after the output reaches a certain level, variable cost increases faster. So the average variable cost will eventually increase with the increase of output. It can be seen that when the output level is low, as the output increases, both AFC and AVC show a downward trend, resulting in the average total cost AC curve decreasing at first. Since the AC and AVC curves are gradually approaching, and the AVC curve will eventually increase, the AC curve will inevitably increase after output exceeds a certain level. Therefore, the short-run AC curve must be U-shaped. Let's go back to the total cost function. If we take a first derivative with respect to the output level, we get the marginal cost, which reflects the change in total cost caused by one more unit of product produced. Since output changes in the short run only lead to changes in variable cost, the short-run marginal cost is also equal to the change in the variable cost caused by one additional unit of output. That is, the derivative of the variable cost function with respect to y. Recall our total cost curves. The total cost curve is always parallel to the variable cost curve. That is, at any given output level, the slope of the two curves must be equal, and their slope is marginal cost at this output level. Since marginal output is the derivative of variable cost, the variable cost must be the integral of marginal cost. As shown in the figure, at any output level y prime, the shaded area below the marginal cost curve represents the sum of cost increase incurred during the process of increasing production from 0 to y prime, which is the total variable cost of producing y prime units of output. According to production theory, the marginal product of factors must eventually be decreasing, so that the growth rate of the total cost curve and variable cost curve must eventually become faster. That is, the slope of the two curves becomes steeper, so that the marginal cost must eventually show an increasing trend. We next use mathematical tools to discuss the trend of the AC curve. If we differentiate the AC function with respect to y, the sign of the resulting function shows whether the slope of the AC curve is positive or negative. If we rearrange the function, we can see that if the marginal cost is greater than the average cost at some output level, the slope of the average cost curve is positive. That is, average cost rises as the output increases. Conversely, if the marginal cost is less than the average cost, the slope of the average cost curve is negative. That is, the average cost decreases as the output increases. Why is there such a correlation between marginal cost and average cost? We might as well use an example to illustrate the relationship between margin and average. Suppose there are 10 children weighing their weights. Their average weight is 30 kilograms. If we have another child with a weight of 40 kilograms adding to the group, her weight exceeds the average weight of the original 10 children. That is, the marginal weight is greater than the average weight. Then, if we calculate the average weight of the 11 children, it is not difficult to find that it must be greater than the average weight of the original 10 children. That is to say, when the marginal value is greater than the average value, the average value will be pulled up by the marginal value. Conversely, when the marginal value is less than the average value, the average value will be pulled down by the marginal value. We use a graph to describe the changing relationship between average cost and marginal cost. As shown in the figure, on the left side of the lowest point of the AC curve, average cost is greater than the marginal cost, so the average cost is decreasing, and AC curve gradually approaches to the rising MC curve. Once the two curves intersect, MC will start to exceed AC, which will drive the average cost to rise gradually. Therefore, the intersection of the MC curve and the AC curve must be the lowest point of the AC curve. In the long run, the producer can build any size of factory it wants. It can choose different types of equipment in a very wide range. It can choose different numbers of production equipment and different sizes of factories for production. The long-run adjustment of the producer's input of all production factors means the adjustment of production scale. In other words, in the long run, producers can always choose an optimal scale for production at each output level. Therefore, the producer's long-run production decision can be seen as choosing the optimal production scale among the numerous short-run production scales. As shown in the figure, suppose a producer has 3 short-run total cost curves, represented by the green, blue, and red curves. The intercept of the total cost curve on the vertical axis is the fixed cost. So the 3 curves represent 3 different production scales. In the long run, producers can choose the optimal scale among these 3 scales for production. As we can see, when the output is between 0 and y prime, the green cost curve is the lowest, which means that it is the best production scale. When the output is between y prime and y double prime, the optimal production scale corresponds to the red cost curve. When the output is above y double prime, the optimal production scale corresponds to the blue cost curve. In other words, if a factory has fewer orders, it is better for the producer to build a smaller factory. If the order volume is larger, the factory needs to expand production. The producer always chooses the production scale with the lowest cost in the long run, so the lowest segments of all short-run total cost curves constitute the long-run total cost curve. The long-run total cost is the lowest total cost that the producer can achieve by changing the production scale at each output level in the long run. The long-run total cost curve is the lower envelope of all short-run total cost curve. For the same reason, let's look at the short-run average cost and the long-run average cost. Since the average cost is equal to the total cost divided by the output level, the production scale with the smallest average cost must also be the smallest total cost. So in the long run, the producer must also choose the production scale with the lowest average cost. As shown in the figure, when the output level is Y1, scale 1 corresponding to the short-run average cost curve as AC1 is optimal. According to this scale, we will find the average cost and marginal cost at Y1. When the output level is Y2, scale 2 corresponding to the short-run average cost curve as AC2 is optimal. And according to scale 2, we find the average cost and marginal cost at the output Y2. By this analogy, we can find the optimal production scale at any output level. Then find the average cost and marginal cost according to the cost function at this scale. In this way, we obtain the trajectory of long-run average cost and long-run marginal cost. Similar to the long-run total cost, the long-run average cost curve is also the lower envelope of all short-run average cost curves. The long-run changes in the scale may have different effects on the production cost. With the expansion of production scale, if the long-run average cost decreases, it means that the expansion of scale brings efficiency. We call it economies of scale. Conversely, when long-run average cost increases as output increases, we call it diseconomies of scale. The long-run average cost curve will usually be U-shaped, which means that producers can often enjoy economies of scale when the production scale is relatively small, and when the production scale reaches a certain level, they will eventually face diseconomies of scale. Why is that? What causes economies of scale and what causes diseconomies of scale? We will leave this for you to think after class. Alright, in this lecture, we examined the changing of the total cost, average cost, and marginal cost of the producer, and the relationship between these cost curves, and analyzed the relationship between short-run cost and long-run cost. That is all for the producer theory. From the next lecture, we will start our discussion on the market structure. We will put cost function discussed in these two lectures into the producer's profit function and analyze the producer's profit maximization problem in different market environments. Hope to see you soon.